good morning, everyone. If you will please grab the warm-up sheet from the front of the desk. You need to have out your homework from last week, which I believe were worksheets 2 and worksheets 3. I'm going to give you your answers for that. But I'm going to go ahead and get started on your warm-ups for me, please. And we'll turn those in on Friday. Okay, so out on your desk, you should have worksheet 2 and worksheet 3. The answers to worksheet 2 are here. If you will take a second to check your answers. And Ms. Burns, if you don't mind just pausing it so they can get that down, please. And then I'll scroll up a little bit for the rest. And then here are the answers for the back part. Ms. Burns, you can pause here as well for the back part. And then you have worksheet 3. Again, Ms. Burns, if you don't mind just pausing so they can check their answers. Scrolling down to the bottom. And then on the back side. And then here are the graphs. Here for those other problems. Okay. All right, so today we're going to talk about writing equations of parallel and perpendicular lines. We've already talked about parallel, which means that they have the same slope. And we've talked about perpendicular lines where we use the word or. And with or, that means opposite reciprocal. So the opposite means a positive and a negative, where the reciprocal means that you're going to flip your numbers. So let's see how we apply that to our news. Okay, so remember again, parallel, the slopes are the same, and perpendicular opposite reciprocals. The slope-intercept form of a line equals y equals mx plus b. On this one, your worksheet may be just a little different, so you can maybe jot this down in your journal. We have two equations, and we determine if they are parallel, perpendicular, or neither. Remember, you're just going to look right at your slope. You don't care about your y-intercept. But I have one that's positive and one that's negative. And 5 as a fraction is 5 over 1, so those numbers are flipped. So this one would definitely be perpendicular. On B, again, we're looking at our slope. Notice that they are not the same, so they're not parallel. And the numbers are not flipped. So this one would be an example of neither. And then on the final one, remember when they do this crazy thing with x, there's a number 1 here. So that really means that my slope is 1 over 2. And my slope on this one is also 1 over 2, so that means these would be parallel. Okay? Then on the next one it says which two lines are parallel. They're asking about each individual set. What you may want to do is just have a little bit more space. I don't think I can undo that. But they're comparing these two lines. So remember, what you're going to have to do first is you're going to have to say 2x plus 5y equals 6. You have to solve that first. So now I have 5y is equal to negative 2x plus 6. Divide by 5. So now I know that y is equal to negative 2 over 5x plus 6 over 5. And I would have to do the same thing with this second equation right here. 5x plus 2y equals 10. Subtract 5x from both sides. And then I would end up dividing by 2. So now I have y is equal to negative 5 over 2x plus 5. And at there, I can then go back and look at their slopes. Do they have the same number? No. Are they opposite reciprocals? No, they're both negative. So on this one, it would be neither. So go ahead and work the next 3. Ms. Burns, if you'll pause and give them time to work those 3, and then restart it here in just a minute. Okay, so on G, I went and actually solved out both equations. This is what you should have had on your paper. The slope for the first one would have given me negative 3 over 4. The slope for the bottom one would have given me 3 over 4. They're not the same because one's positive, one's negative, but my numbers are not switched. So again, on this one, my lines are going to be neither. So Ms. Burns, if you'll pause for H. Okay, and for the next one, I went through and solved, and I found out that the slope for the top one is negative 2 over 5 here, and the slope for the bottom one was 2 over 5, so again, that one is neither. Okay, and then I worked out J here. What I want you to notice that when I first glance at it is that both of them don't appear to be the same. However, if I look at negative 6 over 8, I know that I am capable of reducing that. Half of 6 would give me 3, and half of 8 would give me 4. So that means that my slopes are both the same, so this final one is parallel. So I want you to be careful that you need to make sure that you're reducing all of your answers when you get to slopes. Okay, so on these, we're going to write an equation of a line, but they already have an equation of a line right here. But they want to write a line that is parallel to the given line. So be careful on your test. There should be a question that could possibly come up that says, I don't want to know the equation of this line. I want to know one that's parallel to it. So if this is my equation, the first step I need to do is to find the slope. So the slope on this one here is 5. I want to be able to use the exact same slope because I want the lines to be parallel. And then I have to use the point that's given in order to find out what my new y-intercept is. Okay? So what I would do is I would go ahead and I would graph 0.45, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay? And then I'm going to use the same slope. The slope here is 5 over 1. So from that new point, I'd have to go up 5 and over 1. Which, if I'm looking for my y-intercept and I keep going this way, I'm never going to get across the y-intercept. So I have to go down 5 and to the left 1. And I have to keep doing that until I hit the y-intercept. Well, I'm going to do it one more time, and then down here I would actually hit it. So right here, that would be what? 5, 10, so at negative 15 is where I would hit my y-intercept. So my new equation is going to be 5x, and then my y-intercept it would hit at negative 15. So that would be an equation of a line that was parallel to it. Okay, on the next one, same thing. I want you to try. Okay, so the first thing is I'm going to graph the point 0, 4. So 0, 1, 2, 3, 4. That would be my point. And then I would graph the slope of this line, which is 3 over 1. So here I'm going to have to go up 3 and to the right 1. Up 3 to the right 1. Okay, so right here, this would be the line. Oh, look at that. The first point we graphed was the y-intercept. So if you notice that when x is 0, so then on my new line would be y is equal to 3x plus 4. Anytime that this x is 0, then I can put the number here, and I really don't need to graph the points. And if I graph this other line, it'd be at negative 7, which would be here. And again, I'd go up 3 and over 1. So what you should find out is that your line should be parallel to one another. And then for the last one, I would graph 4, negative 2. And then, see here, I can't just look at it for my slope. So on this one, I'm going to have to go back and solve my equation, like what we were doing before. Divide by 4. So I know that y is equal to negative 5 over 4x plus 2. And I know that my slope is negative 5 over 4. So from this new point, I need to go down 5 and to the right 4. Or I can go up 5 and to the left 4. And my new y-intercept is this point here, which hits at 3. So my equation of my line that is parallel would be y is equal to, use the same slope, negative 5 over 4x, and then my new y-intercept is at 3 because it came to that point right there. Okay, so now on this one, they want us to write an equation that passes through 6, 2, and it is parallel to the line that goes through these 2 points right here. So it has to go through 6, 2. Let's graph that. 6, 2 would be right about here. And I want a line that is parallel to a line that passes through these other 2 points. Well, I can graph those other 2 points. Would be here and 0, 4. And so here's my original line that passed through those 2 points. And now I need to write an equation of a line that passes through 6, 2, which is this point right here. And it's parallel. Well, I can do slope here, up 2 and over 1, 2, 3, 4. So from here I could go up 2 and over 4. That would be my next point. Or I could go down 2 and to the left 4. Right? And I keep going. Are we good? The problem is, where's that y-intercept? The y-intercept will be at -1. So that means that my equation is y is equal to the slope, which we said is a positive, up 2 over 4. Or if I reduce that, it's really 1/2 x, right? And then my y-intercept would be at -1. Now I do want to show you that there really is a formula for slope. It's y2 minus y1 over x2, that's a y right here, and then x2 minus x1. So we have our x and our y, our x and our y. These are my first ones, these are my second ones. And my y2 would give me 4 minus 2. My x2 would be 0 minus a -4. So 4 minus 2 is 2. Right here these become a positive, so that would be 2 over 4. 2 over 4 reduced becomes 1/2. And notice I got the same thing. Okay, so on this one, it looks a lot like what we just did. And you're thinking, well, we're going to do the same thing. The difference is now we're going to be talking about perpendicular. Remember with perpendicular, we talked about or. O meaning opposite, one positive, one negative. And R, reciprocal, means that one of them is going to be flipped. So first I have to come to the equation and find out what's my slope. My slope is 3 over 1. So if I do the opposite reciprocal in order to find a line that's perpendicular to it, this was a positive, so this becomes a negative, and I take those 2 numbers and I flip them. Okay, if I were to graph that original equation, I get this first blue line right here. It says that it needs to pass through this point, so I've graphed 3, 2 here, and now I need to use my slope. So from this new point, I need to go down 1 and over 3, down 1 and over 3. So now this new line, what they're saying is if I graph it properly, that creates a 90-degree angle. Okay, same thing for this next one. Is that here's my new point that I want to graph. It tells me that my graph starts at -3 and up 1 and over 4. So your original line is going to look like this. I want one that is perpendicular to it. So I'm going to write the word or. This is a positive 1/4. That means my new one needs to be a negative. And I need to flip that slope to be 4 over 1. So from my new point, I need to go down 4 and over 1. Down 4 and over 1. And this line right here will make my perpendicular. Okay, and then on this one I graphed my point 5, -7. Here I'm going to have to solve this equation first. So I'm going to have 2y is equal to -5x plus 10 divided by 2. So now I know my slope is -5 over 2. If I'm going to do or, then I need to take it to make it a positive. I need to flip it to be 2 over 5. And then from this point I can go up 2 and over 5. Or I can go down 2 and over 5. So my y-intercept is at 1, 2, 3, 4, 5, 6, 7, 8, 9. So y is equal to, my y-intercept is at a -9, and my slope needs to be 2 over 5x. So that's writing that equation. Okay, and on this last problem, if I graph -4, 9, that gets to this point right here. I graph the point 0, 2 here, and 3, 3 here. So my slope of this line is up 1 and over 3. The problem is I made a mistake here, and what you really want is a line that's perpendicular. So my slope for this one is 1 over 2. Remember, you have to do the or, which means it's going to be -2 over 1. And I have to go through the point -4, 9. So from there, I'm going to go down 2 and over 1, down 2 over 1. So my equation would be y is equal